Find all the roots by using sum and a product of roots of polynomial theorems and factor each polynomial. E. 3 minus I is the root. Based on conjugate root theorem, 3 plus I is also the root. Based on this formula, we know n equals 4. There are 4 roots for these polynomial functions. A sub n equals 1. A sub n minus 1 equals negative 10. A sub 0 equals 10. So x1 plus x2 plus 3 plus I plus 3 minus I equals 10. x1 times x2 times 3 plus I times 3 minus I equals negative 1 to the 4th power times 10 over 1 equals 10. Simplify. We got x1 plus x2 equals 4. x1 times x2 equals 3 plus I times 3 minus I. We do know a plus bi times a minus bi equals a squared plus b squared. 3 squared plus 1 squared equals 10. So x1 times x2 times 10 equals 10, which means x1 times x2 equals 1. For x1 plus x2 equals 4, we can get x2 equals 4 minus x1. Then we plug into this equation. We got x1 times 4 minus x1 equals 1. Distributive property, 4x1 minus x1 squared equals 1. Then move everything to the right side so that the coefficient of x1 squared is positive. x1 squared minus 4x1 plus 1. We cannot factor this quadratic function. We have to use a quadratic formula. A equals 1, B equals negative 4, C equals 1. So x1 equals negative b is 4 plus or minus square root. Negative 4 squared minus 4 times 1 times 1 over 2 times 1 equals 4 plus or minus 16 minus 4 is 12. 2 square root of 3 over 2. Reduce 2 plus or minus square root of 3. Then we can draw the conclusion. The roots of this polynomial function, 3 plus or minus I, and 2 plus or minus square root of 3. For factor f of x equals, this is one factor, x squared minus 4x plus 1. This factor gives us these two roots. We need to figure out the factor with the roots 3 plus or minus I. We do know 3 plus I plus 3 minus I equals 6. 3 plus I times 3 minus I equals 10. So the Villatas form of this quadratic function will be x squared minus 6x plus 10. So we get another factor for this polynomial, x squared minus 6x plus 10. Let's go to f. 3 minus the square root of 2 is a 0. Then 3 plus the square root of 2 is also 0 of this polynomial function. A sub n equals 1. A sub n minus 1 equals negative 6. A sub 0 equals 63. Since n equals 4, there are 4 roots for this polynomial function. x1 plus x2 plus 3 plus square root of 2 plus 3 minus the square root of 2 equals 6. x1 times x2 times 3 plus square root of 2 times 3 minus the square root of 2 equals negative 1 to the 4th power times 63 over 1. It's 63. Then we need to simplify. Cancel. We got x1 plus x2 equals 0. 3 plus the square root of 2 times 3 minus square root of 2. Using the formula a plus b times a minus b equals a squared minus b squared equals 3 squared minus square root of 2 squared equals 7. x1 times x2 equals 63 divided by 7 equals 9. From the first equation, we can get x1 equals negative x2. Then we plug into the second equation. Negative x2 times x2 equals 9. x2 squared equals negative 9. x2 equals plus or minus square root of negative 9, which is plus or minus 3i. Let's draw the conclusion. Roots. 3 plus or minus square root of 2 plus or minus 3i. F of x. From this, we can figure out the factor x squared plus 9. Since 3 plus square root of 2 plus 3 minus square root of 2 equals 6. 3 plus square root of 2 times 3 minus square root of 2 equals 7. We can get Vieta's form of this quadratic function, x squared minus 6x plus 7. So f of x equals x squared plus 9 times x squared minus 6x plus 7.